Alright, in this video we'll see how to calculate the present value of a single payment, then of an annuity, and finally of a series of uneven cash flows using Microsoft Excel. Alright, this is our first problem where we'll see how to calculate the present value of a single payment that is made in the future. So in our case, there is a $50,000 payment after 5 years and there are no other cash flows in between. So we need to calculate just this $50,000 present value. Now the interest rate for this problem is 7% annually. And then this table shows the different compounding frequencies. For example, if the interest rate is compounded quarterly, then the compounding frequency is 4. For monthly compounding, it is 12. We'll see how this table gets used, but first let's consider the simplest scenario where the annual interest rate is 7% and the interest rate is also compounded just annually. Then what would be the present value? To calculate that, select any cell, then press the equal sign, then start typing PV and then select this PV function from the drop down menu. And you'll see that it takes several parameters. The first one being the rate. This rate is the interest rate per period. Since first we're calculating for annual compounding, we can just directly select this cell. Then the next parameter is the number of periods. The number of period is 5 because we'll receive the money after 5 years, right? So select this cell. Then the next parameter is payment. This one is used to input the cash flows of an annuity. In this case, we don't have any annuity, so we'll just keep it to 0. In the next problem, we'll see how this parameter gets used. Alright, then press comma. Then the future value is 50,000, so select this cell. Then again comma. And finally, the last parameter is optional. If we put 0 here, that basically means is that we'll receive the cash flow, the future cash flow of $50,000 at the end of the 5th year. And if we put 1 instead of 0 here, then it means that we'll receive the last year's payment at the beginning of that year. Since we'll receive at the end of the last year, we'll just put 0 here and close the bracket and then press enter. And as you can see, our present value is 35,649. Now what if instead of annual compounding we had a different compounding frequency? What if our interest rate compounded 4 times in a year? So we had quarterly compounding. In that case, we need to adjust our rate and also our compounding total number of periods. To do this, we'll divide our yearly rate by the compounding frequency, and in case of the total number of periods, we'll multiply the number of years with the compounding frequency. So let's do that in this cell for quarterly compounding. So press the equal sign, then select the annual rate, then divide it by the compounding frequency, which is 4. Then press enter. And the total number of periods now would be, again, equal sign. Number of years is 5. So select this cell, then multiply it with the compounding frequency. Then press enter. Now to calculate the present value, again press the equal sign, then select this PV function, then rate should be this cell now, comma, number of periods is this cell, comma, again payment is 0, comma, the future value is same as before, comma, and again keep it to 0, close the bracket and press enter. As you can see, this time the present value is 35,341. And in the same way, we can change the rate and the number of periods of monthly compounding. So for monthly compounding, it will be this divided by this one, enter, and number of periods is this multiplied by this frequency, and then use these variables here to calculate the monthly compounding. I'm sure you can do that by yourself, so I'll not do this. Let's move to the next problem that deals with annuity. Now what you have here is two problems of annuity. In the first problem, we have cash flows that are made at the end of each year, whereas in the second problem, these cash flows are half-yearly cash flows. So this one means after first half year or 6 months, this is after first 6 months, or this is after 1 year, and so on. Let's see the timeline of these cash flows to make it a little bit more clear. So what you have in the first problem is this, where this is the present moment, and after 1 year we receive $50,000, then after another year we receive 50,000 more, then finally after 3 years we receive another $50,000, and the annual interest rate is 7%. Now for the second problem, we will receive $50,000 in each year, but we will receive this $50,000 in 2 equal payments. So in year 1 we'll receive $25,000 after 6 months, then again after another 6 months we'll receive $25,000. So in total it is $50,000, but received at different frequency. All right. So the annual interest rate is 7%, but when we'll be solving this one, we need to make sure that the interest rate is converted to semi-annual period basis, because we're dealing with semi-annual cash flows here. And also we need to adjust our total number of periods also, again like we did before, from the compounding frequency, then divide by C and multiply it by C and so on. We'll see how to do that. All right. Let's see how to actually solve these problems. So first we'll solve the problem with yearly cash flows. To do it, we'll be using the same PV formula again. So press the equal sign and select the function. Then the first parameter is again rate. Since this time it's yearly cash flows, we'll just use the annual interest rate. So select this cell and press comma. Then the number of periods is 3 years. Then payment this time is $50,000 in each period or in each year. So select any one of these 3 payments. Let's say we select this one and then press comma. Now the future value is 0 this time, so put 0 here. And finally for ordinary annuity, select 0 and close the bracket and press enter. So this is the present value of this annuity. If we try to calculate the same thing for annuity due, what we'll do, we'll keep everything else the same. Just in case of the last parameter, we'll put 1. So this is the result for annuity due. Great. Now for dealing with semi-annual cash flows, so we're talking about this problem now. We need to convert the annual interest rate into semi-annual interest rate. We're assuming here that the interest rate is also compounded semi-annually. So the cash flows are made semi-annually, the interest rate is also compounded semi-annually. Only then we can use the formula that I'm just about to show you. All right. So to get the parameters, first let's get the interest rate per period, that is annual interest rate divided by the compounding frequency. So the annual interest rate is this cell divided by the compounding frequency. For semi-annual compounding is 2. Select this cell and press enter. Then the total number of periods equals to a number of years multiplied by the compounding frequency. Now let's use these variables here to calculate the present value of this semi-annual cash flows. Press equal sign, then select the function. Now this time the rate is this cell, comma, the number of periods is this cell, comma, the payments, select any one of these cash flows. Let's select this one, comma, future value is again 0, comma, finally for ordinary annuity select 0, close the bracket and press enter. So this time the present value of the semi-annual cash flows with semi-annual compounding is this one. Alright, in the same way you can do it for the annuity due. Just change the last variable. Alright, now for the final one, let's see how to solve this problem where in the next 5 years we'll have uneven cash flows. For the first year we'll receive $50,000 and in the second year we'll receive $6,000. Then we have to cash outflows, then and again a cash inflow, and the annual interest rate is 7%. So this time we are calculating everything on just annual basis. Now to get the present value this time for uneven cash flows, we'll be using the NPV function. So press the equal sign and get the function, and you'll see that the first parameter is the rate. The annual interest rate is 7%. Then we need to give the values of our cash flows, and of course in chronological order. So year 1's cash flow should be given first, then year 2's cash flows, and so on. What we'll do, we'll directly select all of these cash flows. To do this, select this cell and hold down the shift button and then select this cell. This will select all the cash flows in between. Then close the brackets and press enter. And as you can see, the present value of all these cash flows is $75,393. Alright, that's all for this video. See you in the next one.